something that, well, it will always be something that relates to the topics we're learning. So it'll have to do with the math we're learning, but it's meant to get you to kind of think some more, to extend, and ultimately grab a little grade. It has to do with the application concepts from a couple days ago. So look for that, but I don't want you to worry about it. Kids tend to do better with it because you've now seen it a few times. So yesterday, could you apply yesterday to this little thinker? Why is the sine of 270 equal -1? I'm not going to make you write it down. You're not going to like submit it, but what are you thinking? If you want to share with a neighbor, it's a good share thing. Does your neighbor's idea sound good? Does yours sound good? It's something that will show up on a test, something like this, for you to be able to say why this is true. You don't want to just say, because the calculator says so. We actually haven't really used the calculator, but make sure you get the key ideas. Y value, did you say that or hear that? So -1's a Y value. And by the way, that's because this is sine. So sine is a Y value. Make sure you talk about the angle. Okay, it's at a certain place. It's at that angle. And of course, on the unit circle. All right. Oh, somebody want to fill Gabby in? So let's practice it. We're going to talk about the unit circle. All right. Now, here's something that it's just kind of like a little sidebar. I could talk about it tomorrow. We could talk about it yesterday. Let's talk about it today. This is the X and Y axis, and it's just true that sine will always be positive and cosine will always be positive in this quadrant, right? It's just a simple statement about X and Y. So sine and cosine are always positive in that quadrant. This will be something that you kind of refer back to, and you'll start to understand why I'm showing it to you. But actually, you can kind of develop this, because how about this quadrant? And you can just kind of put this in your notes. Again, it fits anywhere. So sine would still be positive. It's a positive Y value. But now cosine would be negative. Cosine would be negative. You want to take a moment and just kind of think about positive and negative? Do you have any questions? Not something to memorize, but to completely understand, because sine and cosine are just Y and X values. Okay, and they're always going to end up on the unit circle. So, they're always going to end up on the X and Y axis. So there's always going to be a positive and negative manner to them, which obviously fits with those kind of values. Now, let's kind of just continue from yesterday. You're going to find out quickly that it's a little different scenario, yet it still relates. And so I want to consider with you a theta created with the point 3, 4. So again, it does sound a little different, but we're going to show you how it's similar. So we've got a theta created with the point 3, 4. Now, what we want to consider about this theta, and by the way, that's an angle, is going to be the sine of theta and the cosine of theta. So we're going to want to find the sine and cosine of theta. Okay, now just by the way, yesterday we had an angle right there. It was 90 degrees or it was 45 degrees. Now it looks like I don't have an angle. So, boy, geez, what am I going to do? Well, yesterday we said that sine is equal to y and cosine is equal to x. Oh, okay, good. I have an x and a y. So maybe sine's equal to 4. Cosine's equal to 3. I got it. Or maybe I don't. Even if you have no idea like where this problem is headed, do you have an idea why there's no way sine can equal 4, cosine could equal 3? Even if you're not sure where the problem's headed, it has something to do with yesterday. There's no way. Why? Where's sine and cosine always located? Or what were you going to say? Good. And why is the radius always 1? Because sine and cosine are always located on, I love the unit circle. Okay, now listen, that doesn't mean the answers are always 1. It just means there's no way the answers can be beyond 1. So there's no way they could be this big. Oh, wait, maybe there's no sine and cosine. No, remember yesterday we said every angle has a unique point. Every angle has a unique point. Now, to help you kind of see this, here's 3, 4. We all know that that point exists. Here's the angle. Okay, we said there was an angle that was made with that point, so that exists. But here's where the action's at. Here's where the action's at. In fact, here's where the action's going to be for the next many, many weeks on the unit circle. Folks, that's what we want to find. We want to find that point. We just want to make sure we understand that that point is not sine and cosine. Excuse me, that point is not 3, 4, because 3, 4 is clearly beyond. Let's call it something different. Let's call it x prime, y prime. Okay, now we're getting a little fancy with some notation, but x prime, y prime just means that it's some x and y that's related to my initial x and y. So what we want to do is we want to find x prime and y prime. Now, it's going to look a little familiar, so I'm going to kind of speed it up a little bit, but it's going to look a little familiar from yesterday. We're going to zoom in on the action. I guess I'm kind of redrawing the sketch, but I want it to be a little bigger, so I'm going to zoom in. Here's my x prime, y prime. Okay, we've got our theta, and again, we kind of have everything that we've been given. Now, our goal is to find x prime, y prime. Let's get this sketch doctored up. Let's make it look really nice. Like, what's some other things that are true? What's some other things that are true? Are you surprised? Okay, that's true. We could think of a triangle for the 0.34. How about the leg of the triangle? Definitely going to be the x value of 3. How about the other leg? Definitely going to be the y value of 4. Where have you seen those numbers together in a triangle? A 3, 4, a 3, 4, 5. It's a 3, 4, 5. Now, by the way, that's a Pythagorean triple, and you could use the Pythagorean theorem to get 5. But we can also call it a special triangle. Now, this is fun, but we haven't really done anything with x prime and y prime. Do you realize that that's really what we need to do? We need to find x prime and y prime. So let's bring it into the excitement here. Let's make a triangle that has legs. So we can label the x leg as x prime. We can label this y leg as y prime. How could we label the hypotenuse? Anna? Because, yeah, don't forget, that's where this is at. So make full use of that radius of 1. We're almost there. You say, where? We're almost ready to find x prime and y prime. If you see the connection, there's a connection here between these triangles. What's true about these triangles? It's not something we did yesterday. We're now in a new place. Connection between these triangles. Thoughts, Julia? Awesome. Similar triangles have the same ratio, so we could set up a proportion. All those ideas kind of blend together. We've got similar triangles. Now, if you're like, whoa, similar triangles, remember, how does it work? They have like all the same angles. This angle right here is shared by both triangles. They both have a right angle. So, well, then this angle would also have to be the same. So we have like 3 of the same angles, similar triangles. Nice concept from geometry. And when you have similar triangles, uh-oh. Did I spell that right? Similar. It has 3 eyes. It looks kind of weird. There's no eye. It does look kind of weird. All right, similar triangles. Let's get that right. But we have similar triangles, so there's proportional sides. Let's make them proportional. Let's like set up a proportion. Here's the cool thing. The hypotenuse sides, we know both of them, so we can take full advantage of that. We can say that 1 is to 5. That is if you're going to set it up in that order. So the small triangle to the big, 1 is to 5. Then we can go to town with the legs. X prime is to 3. And we got ourselves a pretty easy proportion to solve. X prime equals 3/5. X prime equals 3/5. Take your time, process a little bit, see if you can find y prime. See if you can find y prime. Set up a proportion. What did your proportion look like, Ryan? Good answer. How'd you set it up?
I had 1/5.
Good. Good. So you definitely get 4/5 for y prime. Make sure these are more than just some answers here on a Friday morning. These represent this point. And do they make sense? Look, it's smaller than 1, 3/5, 4/5. It even kind of makes sense with the position that it's in. So, okay, that's my x and y. That's my sine and cosine. Okay, actually, it's interesting. Look, sine does equal 4/5. Cosine does equal 3/5. So it does involve the y and x value. It does involve it. Fix it or somehow make sure you get it right. In fact, I want you to notice what it really requires. It requires 3 things. I'm talking about the answers over here. It does require the y value and the x value, but where did the 5 come from? Where did the 5 come from? Of course, it's the hypotenuse of my original point. You see that? It's the hypotenuse of my original point. And so we come up with a little bit of I'll call it a little bit of a fix for yesterday's definition. Now, I'm not going to rewrite the whole thing, but yesterday you had a little box. It said the trig functions. And then underneath it, you had some stuff about like cosine equaling x. Well, I want you to adjust it because cosine does from yesterday equal x, but from today divided by r. And r, we're going to say in a minute, is going to be the hypotenuse. Take your notes from yesterday and just adjust it. Divide by r. So sine would equal y divided by r. And then do you have some space or somehow can you get it in there? Because we already wrote some stuff, but you can say that r is the hypotenuse. Now, if you're saying, why do we use r? Radius, okay, because things involve circles, and that's the way that it's always taught. So I want to make sure I give it to you the same way. But we use r, and of course it represents the hypotenuse. Okay, now sine and cosine are still represent the point, but it's always on the unit circle, and r is able to sort of take us back. R is able to take us back because of the proportions. Now, after we went through this, the idea is that you can use this as a shortcut. So this is going to be the type of question you see tonight. Let me kind of write it out. You're going to be given a theta, but it's based on a point. So that's a little fancy talk, but we've got a theta based on a point. And it's going to be very common to ask you to find the sine and cosine of theta. Now, you can make this sketch. It's fun. I like making it too, even though I kind of do it every period with kids. It's fun every time. Or you can use this definition. And I kind of want you to get comfortable with this definition because it makes a little quick work. As long as you understand that r is really the hypotenuse. So we have to find r. It's a little bit of a sidebar here, but to find r, you're just going to think about the Pythagorean theorem. Unless, you recognize some kind of special triangle. I don't expect kids to recognize the hypotenuse for a triangle that has a 5 and a 12. But the Pythagorean theorem will find that hypotenuse every time. So you kind of do this off to the side, use a calculator, do whatever you got to do. Make sure that you just understand why we're going to end up with 13. Like I said, even if you kind of just punch that in a calculator, make sure you understand why we get 13, and then just write your answer. It's pretty much that easy. Negative 12 over 13, 5 over 13. Okay, now that's all there is to it. As long as you understand, and this is going to be one of the big pushes for this year, I want you to understand stuff, not just get answers. As long as you understand, like, what's being said here. And what's being said is that you have a point at 5, negative 12 that made a theta. Okay, now that theta is technically this entire rotation. So there's that theta. But really, what we're trying to do when we find the sine and cosine of that theta is figure out this point and make sure that you understand that that yellow point would be these two numbers. I want to make sure, so I'm going to write it down. But if you think about it, it even makes sense. Both those numbers are less than 1. Of course, in an absolute sense, you have a positive x value, you have a negative y value. And if you even think about the position of that point, it fits with our sketch. Okay, and that, of course, is sine and cosine. Now, sine and cosine don't get sort of all the fun. There's some other functions that get invited to the party. Okay, there's a trig party, and all 6 trig functions are invited. Yes, there's 6 trig functions. Okay, now what's a trig function? It's just a relationship between points and angles. Okay, so try to keep that straight. It's just relating points and angles. Sine and cosine haven't changed. You say, do I have to write it down again? A lot of people like to have a complete chart, so it's your call. But sine and cosine haven't changed. But 4 more, let's let them in. They're knocking on the door, let's let them in. Tangent. As I said yesterday, you probably have heard some of these words before, but tangent of theta is y over x. So if I have an angle and I want to find the tangent of that angle, it's going to be like taking the y value from that angle and the x value from that angle and putting them into a fraction. Now, each of these 3 have like a reciprocal. It's kind of like the function that came along with them to the party. They have a reciprocal function. The reciprocal function has a new name, but it just takes the 2 values and, of course, flips them. Now, we call that the cosecant. It's called the cosecant, abbreviated CSC. Cosecant is the reciprocal of sine, and so it's y over r. Check that, r over y. Sorry about that, r over y. Secant. Secant is the reciprocal of cosine. So it's r over x. Okay, now just a little pause point here. These are going to be things you want to know. That's kind of my nice way of saying you do need to memorize them. You really do need to memorize these. It's a big part of this year. You'll use them next year. It's not that hard if you spend a few minutes with it, but please understand that sine and cosecant go together, and they don't start with the same letter. Sine with an S, cosecant with a C. Go figure. Cosine and secant go together, but they don't start with the same letter. So be careful with your memorizing technique. Cotangent. Cotangent, abbreviated COT. Cotangent is the reciprocal of tangent, so it's x over y. Okay, so again, you do need to memorize these. I don't give you like a little pop quiz on Monday or on Tuesday where you write them all out, but you might want to kind of give yourself a little pop quiz. Write them out. When you're doing the homework, try to take this away. Try to cover it up and start to learn the definitions through the homework. We're going to do one more problem. I'm hoping that really you'll do most of the problem, but it'll kind of give you an idea of what we mean when we talk about finding the 6 trig functions. I just realized there's one other little statement here that it's worth putting into your chart. This is something that will continue to pop up over the next, again, couple weeks, and you might at that time start to understand like why it's positive. But my answer to that right now is that it's like a distance. It's like a distance from the center, and so that distance is positive. X and Y are the ones that we will make positive and negative. X and Y will kind of give you the direction, but R is kind of like a distance. Thank you. All right. Here's the theta at a point. It's not the exact same thing that we just did over here because you want to find all 6 trig functions. You want to find the sine of theta, cosine of theta, tangent of theta. Now what's happening here is I'm really going to end up writing out these 6 functions, but you kind of get to know them as you write them out. So I want to find the sine of theta, the cosine of theta, the tangent, and then we slide over here to the reciprocals. Cosecant, secant, cotangent. Okay, just kind of pausing because I want to give you a chance to think, okay, so, what is necessary? How do you start to do this? Kind of look at your definitions. Think about even how we did the other example. Okay, and I can see, and it's a good sign that you guys are finding R. Yes, you should be finding R as kind of your preliminary step. Okay, and it's always Pythagorean theorem. How's it going for you? You should be getting R squared equaling 40. R squared equaling 40. Now, I did want to meet you here because I want to make sure before you go any further that you kind of do this with the proper etiquette. We do not want to see the decimal for that. Okay, it's just because these answers with etiquette need to be given in fraction form. So, how about we break up the square root of 40? How about we simplify it? How you think about numbers that are inside of 40, like maybe 4 times 10. And so you can take out the 4 as a 2. You can leave the 10 behind. And that will be your working R value, 2 root 10. So you're trying to honestly fill in these 6 fractions carefully using 2 root 10. Now I want you to kind of learn through working on this, and maybe by glancing back up here, I hope you see that what I've done with sine is I have certainly set it up according to definition, 2 over 2 root 10, but then the 2's cancel. So you get 1 over root 10. And then you say, no square root in the denominator. So you have to, so we got a little extra fun going on here. But we end up with a better answer of root 10 over 10. Now, if you didn't quite get that, that's the point of this problem, to make sure that you realize that's what's needed. So we get a root 10 over 10. Negative 3 root 10 over 10. When all the dust settles, negative 3 root 10 over 10 for cosine. Okay, and then you get the reciprocals. Secant would end up becoming just cosecant would end up becoming just root 10. Looks like secant is going to be root 10 over negative 3, or maybe just better said, negative root 10 over 3. And then cotangent is negative 3. These are trig values. A trig value is the answer to a trig function. In this essence, a trig value is x and y on the unit circle. All right, the rest of these, it's a little harder to kind of say, hey, what's that? Except to say that the rest of these answers are just comparisons of x, y, and r. But in the essence, these two numbers right here all go back to our newfound love. Okay? Questions? All right, get to know them, and your homework will start to help you to do that. I'm going to give you an exit ticket. The exit ticket is relates to, we'll call it a flex question. The flex question relates to angular and linear speed. Okay, now let me give you a piece of paper for it just to kind of